Today we're going to be talking about the Pythagorean Theorem. And if you remember from previous lessons and throughout this whole book, we talked about Pythagorean Theorem. And if you remember, it's a squared plus b squared is equal to c squared. Alright? You have a right triangle. This is A, this is B, and this is C. Alright? So when you're doing this, A and B are legs. These are known as legs. And this is the hypotenuse. This is the longest side. Alright, so that's basically what we need to know. If you know A and B, it's always going to be, if you're trying to find C in this, for instance, it's always going to be A squared plus B squared is equal to C, which is the square root, in order to find C. If you know C and you know B, then you're going to have C squared minus B squared, which equals A, which is the square root of A. If you happen to know C and A, if you happen to know C and you happen to know A, then it's going to be C squared minus B squared is equal to, C squared minus A squared is equal to B, which is the square root. And that'll give you all the answers. So if you know the hypotenuse, you're subtracting. If you know both legs, you're always adding and then taking the square root. Alright, so like for example, on page 545 in your book, it says to find x. The first picture it gives us. We have a picture of a right triangle. And in the book, it gives us 5, 13, and x. Alright? So, since we know that, we're going to use the Pythagorean theorem to find x because it's a right triangle. So in order to do this, since we know the hypotenuse and a leg, we subtract. We go 13 squared minus 5 squared. Alright? So that's 169 minus 25, which is equal to x, which is the square root. So the square root of this is equal to x. So x equals 169 minus 25, which is, give me one second, 4. The square root of that is 12. So x is equal to 12. So that was number 1. So number 1 is 12. The next one, number 2, it gives us the right triangle. Also, number 2, we have a right triangle. And in this right triangle, we know we have this triangle here. This is the right triangle here. And you're trying to find x. In this case, x is the hypotenuse. 8 and 12. So since x is the hypotenuse, you just go 12 squared, you add. So 12 squared plus 8 squared is equal to x, square root of it. So 12 squared is 144 plus 64. So 144 plus 64 is equal to 208. This is the square root of 208. Alright, the next thing we need to do, see if we can simplify. Because 208 is not a perfect square. If you take the square root, you're going to get a decimal. And remember, we don't use decimals. So therefore, we take the square root of 208. Basically, what are the pairs? Well, 4 goes into it. So 4, so you get what? 5, 52. Alright? 4 goes into that, so that's 13. We have a pair. You can keep breaking it down if you want, but since we already have a pair, we know it's going to be 4 square root of 13, which is x. So that is our answer. Alright, the next one. Number 3. Number 3. It says we have this right triangle, and we don't know the leg, so we subtract. Since we know everything else, but we don't know the leg, so all we do is we go 16 squared minus 4 squared is equal to x, which is the square root of that. So that's 256 minus 16, which is 240, which that's not a perfect square, so therefore we take the square root of it. 4 goes in. I'm going to go 10 and 24. It breaks down to, and then that breaks down to, what is it, 6 and 4. That breaks down to 5 and 2. This breaks down to 2 and 3. The 2's are a pair, and then we have another pair of 2's. So we got, the 2's come out, so we get 4. So we have 2 times 2, square root of 3 times 5. So we get 4 square root of 15 as our answer. Alright, so that's our that's our 3 answers for 1, 2, 3. Alright, let's do number 4. On number 4, it says use the Pythagorean theorem, Pythagorean triple to explain your reasoning. Alright, so on this, it doesn't matter if you use the Pythagorean triple or not. If you want to use it, you can. If you use the Pythagorean triple, the key thing is you have to find the GCF of the number. Alright? All it is saying is a Pythagorean triple. You have 3, 4, and 5, right? You know that's going to be a Pythagorean triple. If you take this times 2, right, this is going to be 6, this is going to be 8, this is going to be 10. We know it's always going to work. That's why it means it's Pythagorean triple. So for instance, we have 21. We have 21, 35, and x. Alright? So, we're wondering, what two numbers go into 25 and 35? Well, if we look at it, well, 7 goes into both of them. So this would be 3, 21 and times 7 is that, and 21 times 7, 7 times what gives me 35, which is 5. So in this case, x would be 4. As you notice, it's 3, 4, 5. So it's really 3 times 7 is 21. Well, 4 times 7 is 28. And then 5 times 7 is 35. So therefore, 28 is what x is. Sorry. So we know, well, if we take the GCF of all those, we're going to get 3. 5, well then 4 has to be it, so you take 4 times 7. If you don't like it that way, just use the Pythagorean theorem and you'll still get the same answer. Alright, number 5. On page 546 it says, the main sail of a boat is shown. What is the length of Ln? Well, Ln is the hypotenuse, and so we do the same thing. Ln is the hypotenuse. Alright, so we have this. We want to find x. That's what Ln is. Alright, we know this is 60, and we know this is 45. Well, let's find out if it's a triple. Because if it's a triple, we don't have to use such large numbers. Well, what goes into both these numbers? Well, I know 15 does. So 15 does, this is 4. 15 times 3 is 3. So this is 5. So 5 times 15 is 75. So x happens to be 75 feet. Using the Pythagorean triples. So therefore, our answer is D in this case. You find the GCF of 45 and 60, right? Basically what goes into both those numbers. Alright, well I know 15 goes into 60. I know 15 goes into 45. Well, 15 goes into here 3 times. 15 goes in there 4. Well, I know 3, 4, 5 is a special right triangle. Alright, so those are the Pythagorean triples. And to see what your Pythagorean triples are, you can always just look at on page 542. Those are the common ones. There's 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Those are all your Pythagorean theorem triples. Alright, the last part of this lesson. It says determine whether each set of numbers is acute, obtuse, or right. Alright, so the way you do this is